let us have a discussion on different essential parts of a DC machine. Construction-wise, a DC machine has four main parts, namely field magnet, armature, commutator, and brush. Actually, a DC machine means a DC motor or a DC generator. Constructionally, both are same. If rotor of a DC machine is rotated by means of a prime mover, it produces electricity at armature. On the other hand, if electricity is supplied to the armature, the rotor of a DC machine starts rotating. In first case, where DC machine produces electricity due to rotating rotor, it acts as DC generator. In the second case, where DC machine produces rotation of rotor due to applied electricity, it acts as a DC motor. Hence, theoretically same DC machine can be used as generator or motor. From this point of view, essentially the constructional features of both DC motor and generator are same. Anyway, let's discuss main four parts of a DC machine one by one. For that, first comes field system. The objective of a field system is to create a uniform magnetic field within which the armature rotates. This magnetic field can be created by either permanent magnet or electromagnet. Electromagnets are preferred in comparison with permanent magnets on account of their greater magnetic effects and field strength regulation, which can be achieved by controlling magnetizing current. Field magnet system consists of four main parts: yoke of frame, pole cores, pole shoes, and magnetizing coils. Yoke is generally of cylindrical shape. The yoke acts as a cover frame of machine and carries the magnetic flux produced by the poles. Since the field is stationary, there is no need to use laminated yoke for normal machine. In small machines, cast iron yokes are used because of cheapness, but yoke of a large machine is made of fabricated steel due to its high permeability. Lifting eye, feet and terminal box are welded on the outer surface of the frame. In small machines, the yoke may be of one piece, but for large machines, it is usual to employ a split yoke, the two halves being bolted together. Pole core of DC machine is usually of circular section and is used to carry the coils of insulated wires carrying the field current. Pole cores are usually not laminated and generally made of cast steel. In some cases, these pole cores are laminated and composed of electrical grade steel sheets of about 1 mm thick and insulated with each other. The pole shoes act as a support to the field coils and spread out the flux over the armature periphery more uniformly, and also being of larger cross section reduces the reluctance of the magnetic path. The pole shoes are always laminated to avoid heating and eddy current losses caused by the fluctuations in the flux distribution on the pole face due to movement of armature slots and teeth. Now let us discuss about construction of armature. The purpose of armature is to rotate the conductors in the uniform magnetic field. It consists of coils of insulated wires wound around an iron and so arranged that electric currents are induced in these wires when the armature is rotated in a magnetic field. In addition to providing support to the armature coils, It also provides low reluctance path to the magnetic flux. The armature core is made of thin lamination of silicon steel. Each lamination is insulated from other by thin paper or thin coating of varnish. The armature is made of laminated grain-oriented silicon steel because in DC machine, armature induces alternating current, hence effect of eddy current and hysteresis should be avoided. The slots are either die-cut or punched on the outer periphery of the circular core. Stamping or the keyway is located on the inner diameter. The slots are normally open type and usually placed parallel to the axis of the armature, but are also sometimes skewed at small angle to avoid vibration of teeth. The lamination stamping of armature is usually punched with holes near the shaft to give longitudinal ventilating ducts. Air is drawn in through these ducts to provide effective ventilation. For larger machines, it is not economical to punch out a complete circular stamping on sheet of silicon steel. Armature core stampings in this case are essentially built up of 4 to 8 segments of laminations that are attached to the spider by means of a dovetail joint. Now come to the commutator. The commutator is a form of rotating switch placed between the armature and the external circuit and so arranged that it will reverse the connections of the external circuit at the instant of each reversal of current in the armature coil. It is essentially of cylindrical structure and is built up of high conductivity hard-drawn copper or drop-forged copper. These segments are insulated from each other by thin layer of mica. The segments are held together by means of two V-shaped rings that fit into the V-grooves cut into the segments. Fourth essential parts of a DC machine are brushes. The function of brushes is to collect current from the commutator and supply it to external load circuit of a DC generator. In case of DC motor, brushes supply current to the commutator. The brushes are rectangular in shape and rest on the commutator. These are only a basic idea of construction of rotating DC machine. Thank you.